Hey everyone, and welcome. So today we're going to dive into a really cool idea. What if AI agents could learn to think more like us? Not so rigid, but dynamic, adaptive, and just plain efficient. Let's get into how a brand new framework is making that a reality. So let's start with the big question. Have you ever noticed that a lot of AI agents seem to have only two speeds? They either react instantly with almost zero thought, or they spin up this massive, complex thinking process for every single tiny step, even the super simple ones. And you can probably guess this one-size-fits-all way of thinking is a huge bottleneck. I mean, it's like using a supercomputer to do basic math, or trying to plan a trip to Mars on a simple calculator. It just wastes a ton of time and resources. And for really long, complicated tasks, that kind of inefficiency is a total deal breaker. But what if an AI could actually choose how hard to think about something? Well, that's where our hero comes in. Let's meet CogRouter. It's a new framework designed to solve this exact problem by teaching AI how to think adaptively.
Okay, so let's break that down. CogRouter isn't just another AI model, it's actually a training framework. It's all based on that idea of thinking fast and slow. Basically, it teaches an agent to look at each step of a problem and ask, okay, how much brain power does this really need? It's all about picking the right cognitive gear for that specific moment. So how does it pull this off? Well, the magic is in creating this kind of hierarchy of thought, which is a lot like how we humans think. CogRouter sets up 4 different cognitive levels, everything from a quick gut reaction all the way to deep, careful simulation. First up, at the base, we've got level 1, intuitive response. You can think of this as the AI's muscle memory. For really simple, routine stuff, it just acts. No overthinking, just a direct, fast response. It's pretty much a gut reaction. Now let's move up to level 2, reflection. This is a step up for sure. Here, the agent actually pauses for a second. It looks at its first impulse and thinks, is this really the best way to do this? It's like a quick self-correction, a little moment of thought before it jumps in. Things get a lot more strategic here at level 3, planning. So when a step is more complex, has a few moving parts, the agent doesn't just react or reflect, it actually builds a plan. It thinks a couple of moves ahead to make sure what it's about to do is actually effective. And finally, we get to the deepest level, level 4, simulation. This is for the really critical, high-stakes decisions. The agent basically runs what-if scenarios in its head, simulating different outcomes to find the absolute best path forward. It's a lot like how we'd weigh all the pros and cons before making a big life choice. Okay, so the agent has these 4 different thinking gears. Great, but how does it learn when to shift from one to the next? Well, that's done through this really clever 2-stage training plan. The whole process is broken into 2 key phases. First, you've got something called COSFT, which basically teaches the agent what each level of thinking feels like. And second, there's COPO, which teaches it when to use the right level to win. So this first stage, COFT, is kind of like a boot camp. The AI learns from a bunch of expert examples, where every action is labeled with the correct level of thought. This drills in the fundamental patterns, so the AI gets a really clear idea of what level 1, 2, 3, and 4 thinking looks like in the real world. Then comes stage 2, COPO, and this is where the agent learns to be a strategist. It uses reinforcement learning, which is basically just trial and error. It gets rewarded when it picks the cognitive level that leads to success, so it learns to perfectly match how deep it thinks to how hard the problem is. So that's the whole theory, right? A 4-level system for thinking, a 2-stage training plan, but does it actually work any better? Well, the results are pretty mind-blowing. All right, check out this chart. This really tells the story. See the other methods, GRPO and JIGPO? They're almost always using level 4, that really deep, expensive simulation. They're overthinking everything. But now look at our agent, COPO. It's using this really smart, healthy mix of all 4 levels. It leans on the fast level 1 and 2 thinking most of the time, and only uses the heavy-duty stuff when it's absolutely necessary. That's real adaptability in action. And this, right here, this is the payoff. On these graphs, that pink line is our adaptive coped agent. Just look at how it shoots up way faster and gets to a higher success rate than all the others. By thinking smarter, not just harder, it learns way more quickly and just performs better, period. And what does that efficiency look like in actual numbers? Get this. CogRouter uses 62% fewer tokens than the previous best method out there. That isn't just a small tweak. That's a massive, massive drop in how much it costs to run, making these powerful agents way more practical to use. But here's the real kicker. It's not just about saving money. The paper flat out states that on a key benchmark, it outperforms even GPT-4o by over 40%. So it's way more efficient and it's more effective. That's the dream, right?
Okay, let's zoom out for a second. What does all this really mean? This research is a huge shift in how we think about building AI agents. We're moving away from this brute force idea of always thinking harder to a much more elegant strategy of thinking smarter. And the big takeaway is this. CogRouter is paving the way for a whole new generation of AI agents. We're talking about agents that are not only better at solving really complex, long-term problems, but they can do it with a kind of efficiency that we just couldn't get to before. Which leaves us with a really exciting question to think about. From discovering new science, to managing complex logistics, to just having a better personal assistant. What kinds of problems could we solve if our AI partners could truly think fast and slow and adapt their minds to any challenge we throw at them?